All right, so tonight, like I said, and sorry for the delays, we're going to go over the badges you have put on, and hopefully we can actually get set up to actually get these started printing. Remember that your prints are not graded. They're simply a benefit of the course. So if you don't get to print or something like that, I would certainly like you to have that option. It's the whole point, but that's not what you're graded on. So whatever. But we will be printing these. Should you like them, I'm going to get it, or should you like to, and we're going to get set up with that stuff too. And hopefully tonight we're going to get to work, start discussing the next assignment. All right, but first I just want to review. Looks like quite a few of you have already downloaded stuff, or sorry, uploaded stuff rather. But I just want to first go over again how to get your files from your personal account onto our team's account. So what you need to do, and I'll open up one of the examples here. Actually, I can probably delete one of these because I've already done this. Yes, I'll delete the old one. So what you'll do is open your folder, because unfortunately, one of the things with Fusion is it will not allow you to transfer files between accounts. Why? I don't know, but that's what it is for now. So to do that, you'll take your finished folder, your finished file, go up to File, and then what you'll need to do is go to Export. Now, make sure if this is for re-uploading into Fusion, make sure it is with an Autodesk Fusion 360 archive file, a .f3d file. Make sure that is the case. Export it to wherever you want on your local drive, your computer. Flip floppity bloop. Hooray. That has been downloaded. So now, go down here. There it is right there. Open Fusion. And I can close this file there. Go to my data panel. Upload. Select File from the desktop. Open it. And there you go, Upload. And it will bring it onto your team folder, or vice versa for that matter. If you forgot to change your teams over and you're started working on a file on our teams and wanted to continue at home, I mean, you can access it either way, but that way you could bring it down to your own. That's how you do that. So, like I said, unfortunately, Fusion doesn't have that built in just yet. I don't know why not, but there we are. Now, as far as files go, like I said, title your files properly. Put your name and the assignment as your file title. That way I don't just have a whole pile of badge assignment, badge, also badge, another badge, badge 2. Please make sure it is appropriately filed, just so it's easier for us to find out who is there so we can talk. All right. So let's go over stuffs. I'm going to see where people are. And we'll, of course, do some troubleshooting. But what I want to do is discuss the badges that are finished. And then, of course, I'll stop recording. We'll go through some troubleshooting. But I want to be able to show everybody how to actually 3D print. So let's see here. All right, let's just ask around. Who's is ready and we want to discuss? All right. So let's drag down to here. Cool. Okay. So again, please rename. Sorry, that's fine. Just please rename when you get to it. Okay. All right, Colby, what you got here? Nice. Super good. Yeah, right now it's giving me this code here because probably you have it open as well. Yeah. Okay, that's fine. I'm not going to make any alterations to it anyway. Okay. But very nice. Looks good. Cool. Got a little. You got your name there. Okay, that's fine. So I got your name here. Super good. Multiple extrusions. That's really what we're looking for. That's pretty much what we're going for. Super good. Now, one thing I wanted to just discuss real quick, just to inspect the overall size here. So, okay, you're in inches. Diameter 3 inches. So this is quite small.
Yeah, when I put it in here, it was like minuscule, so I scaled it up.
Okay, so we will likely have to scale it up a fair bit more because one of the things that you're going to run into is text, because ultimately text, you're dealing with fonts, font size, and the thickness of the extruder nozzle. These extruder nozzles are 0.4 millimeters, so anything below it will, many programs will just remove from the file as it's generating G code.
Yeah, it has to be scaled at 1,830.
Okay.
Yeah, I'm a little used to the measurements.
Okay.
I was working too small.
Okay. Well, remember one thing: if you do want to change measurements, if you prefer to work metrically or in metric, there. Remember how you can change is going to document settings and the first drop down your hierarchy tree, and you can change the units. Just mouse over, change active units, and a window will pop up. Unless that's hidden underneath. Yeah, it is. So there you go. So that's how you can change it. All right, cool. So make that change and you should be good there. All right. And who else? The plane, Robbie?
Yeah.
Yep. Okay, cool.
I'm fixing the bottom text right now.
Okay. So I just wanted to go look at a couple of them just for examples and such. Very nice. Looks good. Again, just want to check the diameter here.
Probably a little small. All of my fillets are probably less than 20.
Thanks. Well, good. Might be all right. But we'll look at them here in a few. There you go. All right, so we'll keep looking at a couple of these, and then I want to discuss actually going on to how to print these. So, okay, so we went over some of the files. What I want to do is first talk about file types. Now, I wasn't planning on talking about this, but Fusion just updated with, or rather with its most recent update, it has changed file types or file type options. Now, what that means and what I'm talking about the standard way you would be exporting any of your files for printing would be using one of the more standard actual object types, which are traditionally STL file and OBJ object file. Now, Fusion, along in cooperation with quite a few other current platforms, have gotten together to make a more universal and more current file type called a 3MS. And I apologize because they just uploaded it like a couple days ago. I might have that backwards. It might be a .3 SM, and I just haven't gotten it in my brain just yet. But the reason for this is the more common types is an STL. This is a 20-year-old file type. This is an STL stereolithogram file is basically the original 3D print file type. So what that means is, or rather what that means for us is, it is an effective file type and it holds a lot of information. But what happens with a lot of modern CAD programs, Fusion included, is it does not accurately translate. And that includes things like appearances, so like material appearances you can assign to things within CAD files. If you are custom building supports and such, STL files do not hold any of that stuff. They can, although they can be much larger file types than, say, an object file, they are not as effective and efficient anymore. So Fusion actually has dropped STL file types as an option to save. So one of the things is don't use it anymore. From Fusion, you can't. So there we are. Now the other standard is an object file. An object file can support things like texture maps. So if you are working in something like Blender or Maya, something like this, where you can actually create really complex sculpted textures, object files will hold on to that. object files will hold on to, again, custom supports and things like that for direct exporting to 3D printers. Object files are perfectly fine. Most times, if you're familiar with things like Thingiverse and other sorts of online file hosting or online model file hosting sites, many of them are object files. Nothing wrong with an object file. It's very usable. You probably can, that will translate to any of the printers we have. The brand new one is the .3ms. That one does all what the object file does, only it now is, like I said, has been developed in conjunction with multiple different printer makers and CAD software developers, so that it is more universal across all software platforms. So if you go to save one of your objects, and what you'll be doing is this exactly. So let me open up my R2D2 in progress example here. So to export for preparation for printing, you'd have to make sure to select the object, but make sure it's much better to just select the whole thing. So to the very top of your hierarchy tree, or just double click on the object you're working with, the body you're working with, go to File. Now, this is problematic because if you mouse over 3D print, this is going to say outputs to an STL. Well, what the hell did I just say? That they nixed that. This is for direct printing. You can use export as well. But export as the brand new one, sorry, there we are. I forgot, it's not S at all, it's 3MF. Sorry about that. 3D model format. Might not even be that because I'm still learning that one. So use that one. Now it might not be supported by everything just yet. Like I said, it's literally just been changed in this most recent update a couple of days ago. So the other option is as an object file. Require cloud translation, might take a few minutes. So as an object file, it just has to translate a little bit, that's all. But either way, I'd recommend probably the newest type, might as well, 3MF. Go to export, and it's going to immediately drop it out wherever you've already set up your file saving folder. If it's just to the desktop, it'll be on the desktop. Show in Explorer. Now this is a new type, but it's going to say, there you go. There's your file, version, 3MF file. Okay, so that's the way to offload a design for printing. Okay, cool. Now I've saved it as an object file or .3mf. Super duper. What do I do now? From there, you're going to use any number of different slicer programs. Now for the two PRUSAs we have back here, I like using the dedicated PRUSA Slicer program. There are multi-use programs. The PRUSA Slicer. This is just an iteration that is developed specifically for PRUSA. Other ones will work on PRUSA, but as we were just testing earlier today, there seemed to be a little bit of a discombobulation there. I don't need to set this up. In that usually a printer will print very slowly on the first pass, and using that, it was not doing that. You can always tweak that later, but we're going to go with this. So for our PRUSA printers, yes.
Is it this one?
Yes, PRUSA Slicer. So this you can get from the PRUSA website, which is PRUSA 3D. They go straight to their download site. Let me go back to this. All right, so I've opened up PRUSA 3D. This is the two of the ones we're using most. And just go to their, excuse me, go to their drivers and apps, and it will automatically select. And if it doesn't, make sure you select for either Windows or Apple or Linux if you're using Linux, and that'll bring up the PRUSA Slicer. So from here, it will give you a virtual work pad. This is reflected of exactly the build plate that is on the printers. Now, I didn't set this up. I'll have to go back and redo this because when it asked me to do the wizard, I should have. All right, I guess I'm gonna have to do that. So give me a moment. Let me do this. Okay, so we're back on here, and I'm going to load the 3MF file that I brought up. So my little R2 thing, I can just click and drag, drop it over. It just dropped it outside of the build plate. You'll have these options over here. You can add them or subtract them, trash it. The little button here, arrange, or just press Shift A, will auto arrange what you've got going. So you can see the scale or the scale that I created it at. It's pretty big. If y'all look over at these printers over here, that takes up most of the print bed there. That's a pretty big print. So I probably want to scale that back a little bit. I had originally made this print. The R2 head itself was 122 millimeters wide, and then I added to it. So I could go back into Fusion and shrink it a little bit, or I can shrink it right here. Scale factors over here on the right, these are all locked. If you want to make it non-uniform scale, you can unlock this, but for here, let's say like 80% of the original. So it'll shrink it completely. That's more reasonable. Okay. So I have my print settings, the type of material, and the printer it's going to. I can go to Slice Now down in the bottom right-hand corner. What that's doing, why it's called slicing, it is literally taking that three-dimensional object and making a bunch of slices. Because how a printer works, it's basically just like a regular ink on paper printer. It prints a whole image, only this is with material, and then it adds another paper on top, adds another layer on top, adds another layer on top. That's how these 3D printers function. These. There are other ones that work differently, but for what we're using, that's how it works. So when it says slice, that's what that means. Now this one has a built-in legend. You can look over and see what it means, what the stuff means, zoom in and out. This is going to give you this is actually going to render a rough estimate of how it's going to look as the extruder passes back and forth on it. So it'll give you a rough estimate of the layers and such. If you want, you can look through and slice down through it and actually see the type of infill pattern. An infill pattern is basically just a pattern that is auto-generated so that your object is not hollow. Some things could be printed hollow, this absolutely not. It needs internal supports. So that's what that is. Again, we're going to go through this in much more detail later. I just want to give everybody a rough introduction so that you can see how this works. All right, so it is finished finished slicing, apologies. Export in G code. This is the computer language for printers and most CNC machining equipment. So export, this will now be saved somewhere here, desktop, super good. So it's going to save that way. Now, I'll get into this, I'll record part of the specifics later on how to do this. But what you'll end up doing is to get from the computer to the printer, you have to load it onto an SD card. Our large MakerBot can take a USB card or USB stick. So however you're using, whatever you're using, make sure you're using the appropriate storage device so that way you can actually transfer over there. The difference on, like, say, the MakerBot is you can upload a file directly onto it. It has an internal hard drive. The PRUSAs do not. They have to have the card left in the printer the whole time. Again, I'm going to be recording a separate demonstration on this, so you'll have that isolated. All right, so that's saved. We go to the desktop and find my G-code thingy. Where are you? There we go. Example of that. So that would be taken over to the printer or loaded onto an SD card, taken over to the printer, and there you go. All right. So I'm going to stop sharing here. and I'm going to demonstrate that. Like I said, this will be recorded in a separate video.